Welcome to the deep dive. Today, we're exploring something really, really fundamental if you're building anything new in tech. It's what our sources are calling the definition phase.
Hmm.
Yeah, and we're digging into some fascinating research here, especially a paper on clarity and vision in the definition phase. It really gives this incredible look at the very start of how technology actually comes to life. So, our mission today, to unpack what this definition phase really is, why it's so critical, I mean, absolutely vital, how it shapes everything that comes after, and crucially, how getting that clarity right at the beginning is basically the blueprint for success. Okay, let's unpack this then. The definition phase, it sounds, well, maybe a bit dry, like just step one on a checklist. But the research suggests it's way more than that. So what exactly is this foundational stage?
You're absolutely right. Sounds simple, but foundational is definitely the word. It's that initial, really critical stage for any kind of technological product or system or platform you're building. Uh, think of it like this. It's where the entire architectural blueprint gets meticulously drawn up. So you're identifying the core objectives, you're detailing the functional requirements, really clarifying the concepts, and nailing down that value proposition. What's it for? And what's really powerful, I think, is the analogy the research uses. It's like architecture. Just like a building's blueprint is this clear, non-negotiable roadmap for how to build it. The definition phase does exactly the same for tech. It's really where those fuzzy ideas start to become solid, where concepts become those tangible realities you can actually work with.
Okay, the blueprint analogy makes sense. So sticking with that, what happens if the blueprint is vague? Or, maybe you try to build without one. Why is getting this initial stage right so incredibly vital for success?
Well, that's where things can go wrong fast. Yeah. If you look at the bigger picture, projects that skip this or just don't handle it well, they become incredibly vulnerable. You end up with just fundamental misalignment between teams or what everyone wants.
Right.
Then there's the classic scope creep.
Oh, yeah, always.
Exactly. Inefficient development cycles because people aren't sure what they're building. And then potentially huge redesign costs later on. It gets expensive. But conversely, if you have a really strong definition phase, you massively cut down the risk of failure later. It becomes the bedrock, really. It allows for modularity, for scalability, for solid functionality down the line. It just sets you up for a much smoother development journey overall.
Okay, now here's where, for me, it gets really interesting. The sources dive into the cognitive side of this. We're not just talking flowcharts and documents here, but what's actually happening inside the developer's brain.
Yeah.
How does our brain contribute to this critical innovation stage?
Yeah, this is fascinating stuff. It really shifts how you think about development, doesn't it?
Hmm.
The research describes it as a deeply cognitive process, and it's fueled by specific parts of the brain, mainly the prefrontal cortex, and these things called association cortices.
Okay.
These are basically your brain's executive control centers. It's where creativity really intersects with, that hard analytical thinking.
So how does that play out? What are those brain regions actually doing during this phase?
Well, they're super active in things like strategic planning, conceptual mapping, like building a mind map inside your head, and all the high-level decision-making that happens early on. They're processing what the sources call the knowledge spectrum.
The knowledge spectrum.
Yeah, basically all the bits of information, the ideas, the constraints, everything floating around. And they organize these kind of abstract concepts into workable plans. And this leads to something even deeper the research talks about: learnography and brain page modulation.
Learnography, brain page modulation. Okay, break those down.
Right, so this definition phase actually activates what they call association learnography. Think of it as how our brains build these interconnected webs of knowledge, linking related concepts together for a specific project. And brain page modulation. That's the brain's active process of structuring these linked concepts into really organized mental frameworks. It's almost like your brain is automatically creating a perfectly organized internal wiki page just for this project's core ideas.
Wow.
And the payoff is huge. It seriously improves memory retention, recall, and even intuitive decision-making throughout the whole development lifecycle because that foundational knowledge is so well structured in your head.
That's incredible. So it's not just about having the ideas, but how your brain actually organizes them for easy access later.
Exactly. It's about making that knowledge usable, intuitive.
So practically speaking then, how could a team manager, or even just one developer, actually encourage this brain page modulation? Are there specific things you can do, exercises maybe?
That's a great question. The research suggests that simply being aware of this cognitive process is a really big first step, understanding that it's happening, but practically. It's about deliberately structuring knowledge, things like mind mapping, using visual hierarchies, creating really structured templates for requirements. Even just taking deliberate breaks allows your brain time to consolidate and process.
Right, letting it sink in.
Exactly. The goal is really to reduce that cognitive load by getting concepts out of your head and organizing them externally, or at least consciously structuring them internally. It helps you think more clearly, like tidying your desk before starting work. It means approaching tech development not just as logic, but as this, deeply cognitive activity.
Okay, so the definition phase is the blueprint. Our brains are the architects.
Yeah.
How do we actually draw the plan effectively? What are the practical steps? The pillars, the sources mentioned to make sure we build a rock-solid foundation are the things people often miss.
Yeah, the sources cover a lot of ground, the usual suspects like identifying the problem, requirements, project charter. But if you dig into what often gets, let's say, underestimated, one big one is the rigor you apply to stakeholder mapping.
Stakeholder mapping. Okay.
It's not just listing names. It's about deeply understanding their priorities, which often conflict, right? Understanding their underlying motivations, even their communication styles. The research almost suggests building like a political map of the project landscape, getting that deep understanding early on. It prevents so many arguments and reworks later. It helps ensure the final thing actually meets those varied, sometimes competing expectations.
A political map. I like that. That feels very real world. What else?
Another pillar that often gets rushed is early risk assessment. And I don't just mean the obvious technical risk like, will this tech work? The sources really emphasize anticipating what you might call clarity risks.
Clarity risks.
Yeah. Potential misunderstandings down the road. Requirements that seem clear now but are actually ambiguous. Unstated assumptions that everyone thinks is agreed upon but isn't. If you don't nail those down now, they will derail things later. It's about proactively asking, okay, where could our shared understanding of this whole project just break down?
That's a really crucial distinction, not just what could go wrong technically, but what could go wrong with our shared understanding. Okay, but talking about structure, the sources also bring up something maybe unexpected, applying principles from coding, like object-oriented programming, OOP, way back here in the planning stage. How does something like encapsulation or abstraction fit in when you're nowhere near writing actual code?
It seems counterintuitive at first, maybe, but what's really insightful is how universal those OOP principles actually are. Concepts like encapsulation and abstraction turn out to be incredibly useful even in the, let's say, non-coding parts of development, right from this definition phase.
How so? Give us an example with encapsulation.
Okay, encapsulation. In coding, it bundles data with methods that operate on that data, right? In the definition phase, you can apply that thinking to create modular blueprints, even if they're just concepts on paper at this point. Each module or component has clearly defined responsibilities and interfaces. The benefit, it massively improves team communication. Everyone knows which part of the conceptual system they own or need to think about. Plus, it makes thinking about testing much easier later because you've designed these conceptual components to be somewhat independent. It builds in flexibility from the start.
Okay, that makes sense for modularity. What about abstraction?
Abstraction, hiding complexity. In coding, you hide the implementation details. In early planning, it helps the team hide unnecessary complexity then. You maintain a high-level view of how the system should behave, what the outcomes are, without getting totally bogged down in every single tiny detail right away.
Right, avoiding the weeds too early.
Exactly. And the payoff there is faster decision-making because you're focused on the big picture. And it leads to much clearer technical documentation later because you establish that high-level view first. You're focusing on the forest, not every single leaf, at this critical initial stage.
So we've covered what the definition phase is, the brain science behind it, the key activities, even OOP principles. But let's leap back to the big theme running through all of this. Clarity. Why is clarity just so paramount, beyond just stopping things from going wrong? What does the research say clarity actually enables? Does it unlock something more?
That's a key point. It's not just about avoiding problems, though it certainly does that. The sources really argue that true clarity in this definition stage actually frees up creativity later on.
How does that work?
Well, think about it. When what you're building, why you're building it, who it's for, is absolutely crystal clear and agreed upon. The team can then pour all their energy and ingenuity into the how. How do we build this elegantly? How do we innovate within these clear boundaries? It removes the uncertainty that stifles creative solutions. So clarity actually unleashes innovation. rather than constraining it.
Interesting. So it provides the sandbox for creativity.
Precisely. And that clarity acts as the guiding light, as the research puts it. It gives everyone involved, developers, stakeholders, management, a truly shared understanding of the goals and the requirements. That minimizes the ambiguity and the misunderstandings that, poison projects later. It cuts down uncertainty, makes it way easier to spot potential issues early and deal with them proactively.
Mm.
And there's a really direct finding in the research here. Clarity in the definition phase directly correlates with project success.
It's not
Indeed,
everybody
you're
correlates.
Yeah. Projects where goals and specs are clearly defined right at the start are just significantly more likely to succeed. That means hitting performance targets, staying on time, staying on budget. And the flip side is just as clear. Vagueness, ambiguity in that initial blueprint. It pretty much guarantees delays, rework, and racking up technical debt.
And you can probably think of examples, right? Projects you've been on or heard about that just struggled, constantly changing direction, endless problems. This research really puts a finger on it. That foundation, built with real intentional clarity, it determines the whole path forward. It's quite a powerful way to look at it.
Okay, so let's try and summarize what we've really dug into today.
Yeah.
This definition phase, it's clearly not just some preliminary admin task. It's more like the intellectual cornerstone of any tech innovation. It's the point where clarity becomes actual power, where your vision really starts to shape the invention itself. It sounds like it's the ultimate defense against that horrible moment, maybe 3 months into a project, when someone pipes up and says, wait, is this actually what we all agreed we were building? Exactly that feeling.
Yeah.
And the sources really drive home this implication, saying the definition phase is no longer just a preliminary checklist, but this is the architect's studio, the neurodesigner's interface, and the foundation upon which intuitive, scalable, and transformative technologies are built. It elevates it significantly.
That's a great quote. So a final thought for you, our listener, and this comes right from the research's call to action. We really encourage you to consciously invest that time and maybe more importantly, that cognitive effort into a really well-structured definition phase for your own projects. Doesn't matter if it's a small personal thing or a huge professional one. Maybe try embracing some of this brain science. Think about those OOP principles even early on and just champion clarity like it's the most valuable resource you have at the start. Because it probably is.
Absolutely. Remember, clarity fuels momentum. Begin with clarity, finish with dominance.
Brilliant. Well, thank you for joining us on this deep dive into the definition phase. We really hope this gives you some powerful ideas for your next innovative journey. Keep exploring, keep learning.